Now parallel combination of capacitors. So capacitors in parallel. Suppose the capacitors are connected with the supply as shown in this figure in such a way that one plate of each capacitor that is connected with positive terminal of the battery and other plate of each capacitor that is connected with negative terminal. Then this type of connection of the capacitors that is known as parallel combination. So here in parallel combination across these common points here, the potential difference will be same one. Now capacitance of each capacitor, that is different one. Suppose for this one the capacitance is C1, for second one C2. Now potential difference across each one is same one. Obviously C that is Q by V, V that is same one, C that is different one. So charge deposited on each capacitor will be different one. Clear? So here we can write the net charge Q supplied by the supply or the battery to this entire combination, that we can write Q equal to Q1 plus Q2, where Q1, now C that is Q by V, so Q that is CV, so Q1 that is C1V, Q2 that is C2V. So total electric charge that is Q equal to Q1 plus Q2. Clear? Now substitute these values of Q1 and Q2. So we can write Q that is C1V plus C2V. Take V common, take it on left hand side. So we can write now Q by V that is C1 plus C2. Now suppose here the effective capacitance for this parallel combination is C. Then effective capacitance means same supply will give you the same amount of charge if this combination is replaced by only one capacitor. Then we can write C that is Q by V, but here we can see Q by V that is C1 plus C2. It implies that suppose we have n capacitors connected in the parallel combination, then the effective capacitance, that is C equal to C1 plus C2 plus C3 up to Cn. So from this equation you can say this thing: in parallel combination of capacitors, the effective capacitance that will be greater than the largest one connected in this particular combination. Suppose here we consider each capacitor that is with same value. Then we can write C plus C plus C plus C up to n times. So we can write the effective capacitance that will be n into C, where n that is the number of capacitors in the given parallel combination. Clear to all of you?